Hello guys, so we are back again, and in this session we are going to continue with the binomial type of questions. Okay, binomial questions, different varieties on general term and expansion related problems. But before starting with the session, hope you have subscribed our channel so that we can bring more IITJ mathematics contents for you. Now the question which we are going to take in this session is as follow. The question is this is the question. Now the question says, if a and b are two distinct numbers, prove that a minus b is a factor of a power n minus b power n whenever n is a positive integer. Okay, now you have to just memorize this proof, okay, or just learn the trick. Okay, only one step you have to learn. Okay, whenever you have to prove anything like this, a power n minus b power n to be a factor of this, okay, or you have to prove this is a factor of this. So in that case, what you have to do is just take one term, a power n, do a basic thing. Here I want to prove a minus b, so what I am going to take, add minus b and plus b whole power n. Now I want to create a minus b as a factor, so I will take these two as one term. So treat a minus b as single term and create this b differently. After this, do the expansion. Okay, if you do the expansion, it will be nc0 a minus b power n, right? Then it will be nc1 a minus b power n minus 1 into b power 1. It will be nc2 a minus b power n minus 2 b power 2, and this will go on till we reach the last term, which will be ncn what, b power n, and before it will be ncn minus 1 a minus b b power n minus 1, right? So till here a minus b is common, so this ncn is nothing but 1. So what I can do, I can write this nc0 a minus b power n as it is, and nc1 a minus b power n minus 1 into b, and nc2 a minus b power n minus 2 into b power 2, and so on till ncn minus 1 a minus b power, okay, a minus b and b power n minus 1. Now this is what, this you can write as b power n, as ncn is 1. I have told you to memorize that ncn is 1, and nc1 will be what, n, nc1 will be 1, nc1 will be n, and ncn will be what, 1. So due to this here b power n remains, and this you can shift that side. So a power n minus b power n you will get, and here nc0 a minus b power n plus nc1 a minus b power n minus 1 b nc2 a minus b power n minus 2 b power 2, and so on till ncn minus 1 a minus b b power n minus 1. Now till here a minus b terms are present, so I will take a minus b out. So if I take a minus b out, I will be left with nc0 here a minus b power n minus 1, because I have take one a minus b common, nc1 a minus b power n minus 2, and plus nc2 a minus b power n minus 3 b square, and so on. And here, since I have taken a minus b outside, so here it will be ncn minus 1 b power n minus 1. So here we got this common, so a minus b, we can write this thing as some k constant. So if a minus b can be written as like this, so it doesn't mean it means that a minus b, okay, it just means that a minus b is a factor of a power n minus b power n. Now how you can understand, suppose I can write it, okay, this you can write as 2 into 4, okay, so 2 is a factor of it, okay, hope you have understand. So if you can express anything in this format, okay, so it means that this is a factor, okay, 2 is a factor of this 8. Now hope you have understand this problem, why we represented this, okay, that was the doubt. Okay, you need to know this thing to understand the representation of this. Now let's move on to the next question. The next question is as follow. The next question is this. the next question says find the number of terms in the expansion of a plus b plus c power n where n belongs to natural number. Now here we want to find number of terms, okay, but here the problem is that here it is not a binomial, it is a trinomial, because here three terms are there. So what we have to do, we have to treat it, because we have learned to find the number of terms in binomial only. So what we can do, a plus b plus c, in the previous problem like we considered two variables as a single term, here also we will do the same. But whenever they will tell you to find the number of terms, always do a simple thing, try to consider like this, a plus b plus c, okay, like this. What is the advantage of considering this, you will come to know. The moment you consider a plus and b plus c as a single term, you will come to know the advantage. A nc0 a power n, in the second nc1 a power n minus 1 into here b plus c power 1. After this nc1 nc2 a power n minus 2 into b plus c power 2, and like this it will go on till you reach ncn, right, a power 0 into b plus c power n. Now just understand, here the t1 has one term, here this is a power n minus 1 and this is what, two terms. So if a multiplied with these two, it will give me two terms. So t2 is nothing but two terms. Here t3, now let's observe t3, here power 2 is there, so a square plus 2ab plus b square. Remember, whatever the power is, one more extra term appears, okay. If 2 power is there, then 3 terms will be there in that binomial. So here 3 terms will be there, and when a power n minus 2 will multiply, we will get 3 terms. So in t3 we will have 3 terms. Similarly we'll go on, and here in the nth, this is 0, okay, a power 0 is 1. B plus c power n has how many terms? N plus 1. So in the tn we have n plus 1 terms. So 1 plus 2 plus 3 plus so on till n plus 1. Now sum of n natural number is n into n plus 1 by 2. So sum of n plus 1 natural number is nothing but just replace n by n plus 1. So n plus 1 into n plus 1 plus 1 by 2, which gives you n plus 1 into n plus 2 by 2. So this is your answer. The number of terms in the expansion of a plus b plus c power n where n belongs to natural number. So this question was very good question, because it tells you why you need to expand it like this. Now if you expand it like that, what is the issue? If you expand it like that, what will happen, that if you write, now if I do this thing, okay, what I was telling, if you expand a plus b like this, a plus b plus c power n, okay, what will happen is this thing is right, okay. After this nc1 a plus b power n minus 1 into c, and nc2 a plus b power n minus 2 into c2, okay, c square, and so on. So here the difficulty is you will not be able to, okay, here n terms will be there, here n minus 1 terms will be there, okay, just add 1 here, it will become n plus 1, and when this will multiply n plus 1, so it will be in reverse order, which will make us little bit uncomfortable or difficult to understand. So avoid this and go with this way, okay, it will make you uncomfortable, this will be good, okay. So this way of solving these type of problems, finding the number of terms, okay, is very good. Now let's move on to the next problem. The next problem which we are going to take is this one. Find the number of terms which are free from radical signs in the expansion of y power 1 by 5 plus x power 1 by 10 the whole power 55. Now this is a binomial, and here what we have to target is to get rid of binomial. What does mean radical signs? Radical sign means nothing but, if I have say x power 1 by 5, x power 2 by 5, x power 5 by 3, x power 7 by 5, so these, okay, p by q format, p by q format power is nothing but radical sign, okay, p by q format power is nothing but radical sign, okay. If you have a constant number like thing like x power 2, x power 3, okay, x power 7, okay, these are what, not radicals, and they are simple powers, okay. Radicals means like this, p by q format power, so you have to get rid of this. Now let's write a general term, tr plus 1. So if we write that 55 cr y power 1 by 5, here 55 minus r, here x power 1 by 10 into 50 into r. Okay, so if you simplify, we want to get rid of now these two terms. These two terms are the terms, if this is free from radical sign and this is from free from radical sign, for which r value, then we will get the condition for what value in the expansion of this it will be free for radical sign. So we have to decide which r value will get us that this and this will get free of 1 by 10 and 1 by 5 power, and it will be a simple number power. Okay, it will not be in the format p by q. So just see y power, if I just distribute here 55 minus r by 5 and here x power r by 10, if you simplify it further, y power 11 minus r by 5 and here x power r by 10. Select a number, set as this minus r by 5. Okay, and this r by 10 should get a number simultaneously. So here we can select first 0. If r equals to 0, then they both will become 0 and our power will be 11, and 1 here it will be 0, so x power 0 is 1. So 0 is right. Now can we select 5? Here 5 will give me minus 1 and here y power 10 will appear, that is right. But here we will get stuck, and here if you substitute 5 it will be 1 by 2, which is again a p by q power. So r equals to 5 is rejected, r equals to 5 is rejected. So I got an idea that 10, if I take any 10, it will be a multiple of 5 for sure. So I will try to take all 10 multiples. And what is the limit till I have to go for checking for 10 multiples? 55, because after 55 power, okay, we are not allowed, because r can be between 0 to 55. So we will take r equals to 10, r equals to 20, r equals to 30, r equals to 40, r equals to 50. Right? So we got these r value will satisfy the condition. Now, what is the main problem? Find the number of terms which are free. Now we want to find the term. These are r values. Okay. What is the term position? What is the term? Okay, r value and term position are entirely different. Term position you get by r plus 1. So if you substitute here r equals to 0, you will get t1. So for t1 term, it will be free from radical sign. So here if you substitute 10 to 10 plus 1, it will be what? T11. T11 term will be free from radical sign. T20 plus 1, it is nothing but T21, which will be free from radical sign. T30 plus 1, it is T31, which will be free from radical sign, and simultaneously T41 and T51. So these are the required 1, 2, 3, 4, 5, 6 terms which are free from radical sign, and the position is as follows: T1, T2, T11, T21, T31, T41. Okay, so hope you have understand this problem clearly, how we proceeded. Okay, what is mean by getting free from radical sign, and what format of number should not be there to get it, to make it free from radical sign. Now let's take the next question. The next question is this, which says if k and n are positive integers and sk is equals to 1 power k plus 2 power k plus 3 power k and so on till n power k, then prove that summation r equals to 1 to m plus 1 cr sk into sk is equals to n plus 1 power f plus 1 minus n plus 1. Now to solve this, let's open this summation. If we open this summation, we will have m plus 1 c1 s1, m plus 1 c2 s2, m plus 1 c3 s3, and so on till m. So m plus 1 cm sm. Now each s is nothing but, here I have to substitute instead of k 1, so I will get this s1. So if I want to get this s1, it will be c1. S1 will be what? 1 power 1, 2 power 1, 3 power 1, n power 1. For this S1, k is 1. So if I substitute, it will be 2, 1, 2, 3 plus 4 till n. Now for m plus 2, c2, s2, it will be what? 1 power 2, 2 power 2, 3 power 2, and so on till n power 2. Here our k value is 2 for this. Similarly, m plus 1, c3, it will be what? 1 power 3, 2 power 3, 3 power 3, and so on till n power 3. And if we move ahead to the final one, m plus 2 is written, m plus 1 c, what is the last one? M. S, here 1 power m, 2 power m, 3 power m, and so on till n power m. Okay, now we got this thing. After this, what we are going to do, we are going to select these type of terms. M plus 1 c1, 1 is there. M plus 1 c2, 1 square is there. M plus 1 c3, m cube is there, and so on till m plus 1 cm, n power m. Okay, 1 power m. Now similarly, if we move on, m plus 1 c2, so here m plus 1 c2, 1 square, m plus 1. Here we took all the terms which were of power 1. Okay, now we are going to take all the terms which were of power 2. So we are going to take those terms, right? So if we take this, here what we have, c m plus 1 2, which will be of power 2, and similarly c m plus c2 c3, which will we have 3 power 2, and m plus 1 c4, which will have okay, sorry, we are doing some mistake, 2 power 3. It will be c. Okay, we forgot to write one more term, m plus 1 c1, 1 2, here 2 power 2 square, here 2 power 3 cube, and here if we write 4, 2 power 4, and so on. What is the last term? M plus 1 c, m is the last term, then 2 power m will be there. Okay, similarly if we move on, m plus 1 c 1. Okay, here if I have 3, then m plus 1 c 2, 3 power 2, and here we have what? Here we have something else. Here we have mc1 c3, 3 power 3, and here we have m plus 1 c4, 4 power 4, sorry, 3 power 4, and so on. It will go on till m plus 1 cm, 2 power 3 power m. So here all three terms have came, and so on. It will go until the last, where I will have mc1 c1, here n will be there. Similarly here m plus 1 c2, n power 2 will be there. Here m plus 1 c3, n power 3 will be there, and so on till the last, m plus 1 cm, n power m will be there. Okay, so we will move on like this. And after this, what we are going to do, if you observe clearly, here this series m plus 1 c1 1, m plus 1 2 1 square, m plus 1 3 1 cube, and so on, we are going to just add them. Okay, so if we add them, what you can see now, if you remember one property which I told you to remember, which was, if I tell you 1 plus 1 power n, 1 power x power n can be written as summation r equals to 0 to n ncr x power n. Remember? So here if you observe, if you open this, what do you observe? nc1 x power 1, okay, sorry, x power r, and nc2 is x power 2, and nc3 will be x power 3, and so on till ncn is x power n. So here you can clearly see that we can write this whole summation as 1 plus x power n. Okay, So here you can see this is m plus 1 c1, m plus 1 c2 1 square, m plus 1 3 1 cube, and so on. Similarly m plus 1 c2 1 square 2 square, and here m plus 1 c1 2, m plus 1 c3 2 cube. So here power is increasing like this, and here numbers are changing c1 c2 c3. But if you observe here, there will be one more term nc0 plus, right? So if you observe here, one more issue is there. Here this mc1 c0 is missing, and mc1 upon c mc1 c m plus 1 is missing. So these two terms are missing. So if we add these two terms and subtract, then we can make this. So we are trying to make this. So if we make this, what we will have 1 plus 1 power m plus 1. Whatever here is the power will be the power of the binomial, minus 1 because we have added 1, and minus m plus 1 c m plus 1, what will be 1 power m, right? So this was the term which was missing, so we have added this m plus 1. Now what we are going to do, similarly we are going to do for the next. Here in the second one, here also the first term m plus 1 c0, okay, is missing, and m plus 1 c m plus 1 2 power m plus 1 is missing. So we are going to add that and subtract that. So if we do that, we will have 1 plus 2 power m plus 1 minus 1 minus m plus 1 c m plus 1 2 power m plus 1, and this will keep on going till we reach the last. What will be the last one? 1 plus n power m plus 1. Here all n terms are there. Now the starting term is missing, so minus 1, and the last term m plus 1 term is missing, so m plus 1 c m plus 1 into 2 power n power m plus 1. So we got this thing. After this you can clearly see this minus 1 is repeated till n times, so it is minus n. We can move it out as minus n. And if you observe the rest of the things, we have 2 power m plus 1, and if we collect, this is what? This is nothing but 1. M plus 1 c m plus 1 is nothing but 1, so minus 1 power m plus 1. This is one bracket, and after this is what? 3 power m plus 1 minus 2 power m plus 1. Similarly this will go on. After this, what will be 4m plus 1 minus 3m plus 1, and this will go on till the last term, which will be what? 1 plus n power m plus 1 minus, what is smaller term? N power m plus 1. And here minus n, all minus 1 will add on till n times and will give me minus n. Okay, so after this, what you can see, that this term is getting cancelled out with this. Similarly this term is getting cancelled out with this, and this process will go on, and this will be the only term which will be left, and this term will be the only term which will be left. So we are left with 1 plus n power m plus 1 minus 1 minus n, which you can write as 1 plus n power m plus 1 minus n plus 1. So this was the thing which we wanted to prove, which was n plus 1 power m plus 1 minus n plus 1. So hope you have understood each and every step, and we have proved the required thing. I know this question was very difficult, because to get click this idea that to that we have to collect this term gets from this thing. Okay, if your basics are very strong, then only you will be able to click this step, otherwise you will get stuck in examination. If such type of question appears, if you don't have intense practice of this type problems, try to skip them, because they will consume your time. Now let's move on to the next question. The next question is as follow. The question says, prove that summation r equals to 0 to n ncr sin rx dot cos n minus r into x is equal to 2 to power n minus 1 into sin nx. So in this question, what we are going to do, there is one thing which we have learned in sequence and series, okay, which was adding the series in reverse manner. Okay, you will see why I am telling this. If you open this, let's call it sum s. So if you open this sc0 sin 0x cos n minus 0 into x. If you continue upon it, NC1 sin x cos n minus 1 x, NC2 sin x 2x into cos n minus 2x, and so on till the last term NCn sin nx into cos 0x. So we got this as. Now you will come to know, now you know sin a plus b. Sin a plus b is nothing but sin a cos b plus cos a sin b. So you know that formula. So there is one theorem which is called Gauss reduction, which is nothing but a sequence series thing which we have studied in many times. Okay, in sequence and series, the whole series thing was based on that property only, that you write a series, okay, write a sum, open a sigma, and then you open that sigma and write it in reverse manner and then add both of them. Why we will do that? Because here we want to create sin a plus b. Sin a plus b will be created because if you go in reverse order, there will be sin n minus 0 into cos 0x. Like you can observe, they are just opposite. So there is high probability that we can get sin a plus b. So just write it in reverse manner, which is called Gauss reduction. You can say using Gauss reduction. Okay. So if you do that, if I start write in reversing manner, NCn sin nx into cos 0x plus NCn minus 1, right, sin n minus 1 x into cos x, right, and similarly this process will go until NC0 sin 0x into cos n minus 0x. So if you add this, add 1 and 2, this one is our 1, this one is our 2. So if you add 1 or 2, you will get 2s equals to, now here NC0 and NC1 is what? 1 only. So there is no need of getting and mostly what will happen, the term starting the term from the start and term from the back are nothing but same only by the property of NCR is equals to NCn minus r. So if we go by that property, here we will get sin a plus b, which will be nothing but, you can say it will be sin nx plus 0x, nx plus 0x. So we got this thing. After this, what we can write? You want to write NC0, it's up to you. And here NC1 sin, what we have here is n minus 1 and 1, which will be x plus n minus 1 x. NC2, which will be sin 2x plus n minus 2x, right, and this will go on till the last, which is NCn sin x plus 0x. Okay, sin nx plus 0x, and this will be the end. And if you try to add them, what you are going to get is nothing but all the terms. If you see here, if you multiply, this xx will cancel out and you will be left with sin nx. Here also sin nx, here also sin nx, and all the terms will be sin nx only. So you will be left with NC0, NC1, NC2, NC3, and till so on till NCn. And here we will have sin nx into 2s. So in further, when you move on to series summation, you will come to know that the sum of this series is nothing but, you write it 2 power n. So we will discuss that in detail, but for the timing, just remember that NC0 plus NC1 plus NC2 and so on till NCn is nothing but 2 power n. So this will be sin nx as it is, and this 2 will move here, which will give you s value is 2 power n minus 1 into sin nx. So this is our answer, and in the next session we are going to do some more problems. Okay, so practice these problems and see you in the next session with more problems. Okay, bye.